I'm Ethan Kwan, and today I'm going to be showing you a proof of the product rule and a few other calculus things that I think you'd find interesting. Okay, so quickly to recap, the product rule is basically what it says when you do like multiply two derivatives of functions, and it looks like this. So this is the derivative sign, right? So if you multiply two functions together, let's say f of x times g of x, and then let's say you take the derivative of that, this is the power rule. This is going to be equal to f prime of x times g of x, no prime, plus f of x, no prime, times g prime of x. Now you might be wondering where this comes from, so today I'm going to prove it to you. Okay, so let's say that f of x, well, this is just the definition of a derivative, right? So f of x equals, f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. If you don't know where I got this from, you might want to review somewhere. I don't know, just go, I don't know, somewhere. But if you do know it, great. Okay, so we're going to start the proof now. So let's move that up there. Let's just use this function here and just input f of x plus h, g of x plus h, minus f of x, g of x, so like this. So that means that the derivative of f of x times g of x, we're just going to treat this f of x times g of x as a whole function. So we're just going to put that into here. So what we're going to get is we are going to get this whole function, right? So f of x plus h, g of x plus h, minus f of x, g of x. Now you might be wondering why I put that big weird gap in the middle. Well, that's because we're going to add something in there. Actually, we're going to do two things. I just want to explain that, well, first of all, if we add something and then we subtract something again, obviously that's not going to change the value of the whole thing, right? So if you say take 4, right, and then add 3, which is 7, oh wow, great math, and then subtract 3, that's going to be 4 again, right? So we can add something to this expression as long as we subtract it later on again. So if we do that here, let's say so what I'm going to add and subtract to this is the equation f of x plus h, g of x, and then, so I'm going to just put the negative out front, so negative f of x plus h, g of x, plus f of x plus h, g of x, right? Those two will cancel and they won't do anything. So that will look like f of x plus h, g of x, right? That's the first one. And then plus f of x plus h, g of x. So that will basically, that'll do it, really. Okay, let's move this up here. Okay. Now we're going to just take this part of the equation, and we're going to split it up into its own limit, because that's just limit properties, right? Limit of, and then we're just going to take this, f of x plus h times g of x plus h minus f of x plus h, g of x. Now, notice all I did there was just take that bit of the equation and just put it in its own limit function. Now, I'm going to also take this part of, I'm going to take that part of the equation, and I'm going to put it in its own separate limit. So, let's do that. Limit is f of x plus, as h approaches 0, of f of x plus h plus, times g of x minus f of x, g of x. Now notice that both of them are under, or both of them are over h, which means that, well, both of them are over h. That's just because of limit properties, we have to include the h there. Now, what we're going to do is we're going to, in each of these equations, we're going to factor out, well, in the first one, we're going to factor out an f of x plus h, right? So if we do that, in the second one, we're going to factor out a g of x. So there's 1 and there's 2. Okay, so now what we're going to get is everything else except for that, right? So g of x plus h minus g of x over h. Well, that's the first function, right? So we're going to just put that in there. All right, limit as h approaches 0 of g of x plus h minus g of x. Right, that's just everything without the f of x plus h. Now, we have to not forget the f of x plus h. F of x plus h, sorry about that. So what we're going to do is we're just going to put that out front like that. Now we're going to add to that the limit as x approaches 0, h approaches 0, sorry about that, of this function, which is going to be factored out of g of x, and f of x plus h is, remember, we got rid of the g of x, right? So f minus f of x over h, and then g of x. Great. Now what we can do is we can simplify this a little bit. Let's use some more limit properties. If we multiply two things inside a limit together with each other, we can separate those two into its own separate limits. So you'll see what I mean when I do this. All right, so I took that first function, and then I multiplied it by the limit as x approaches 0 of this thing, this long thing here. I'll wait. Yeah. And then plus the limit as h approaches 0 of g of x times the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, now we can simplify this a little bit. We can put brackets around everything. And there we go. Now, notice that this function right here, this thing, looks a lot like this. Now, actually, it is exactly the same. So we can actually replace that with the f prime of x. Now, notice that this function here also looks like this. It's just a different function. It's just g of x instead of f of x. So what we can do is we can actually just simplify, if we simplify the first one, f of x plus h, if we insert h is equal to 0 to limit as f approaches, the limit as h approaches 0 of f of x plus h, what we're going to get is we're just going to get f of x. Now we're going to multiply that by g prime of x because that's just the definition of a derivative of a function, right? Limit as h approaches 0 of g of x plus h minus g of x all over h, right? Now we can simplify this next expression. There are no h's involved in this expression, so we can just put just the limit there. We can get rid of the limit. We can just trash the limit, and we can also put the red boxed one. That's the definition of f prime of x. So we can just put that. So we can combine all this together, and we get f of x times g prime of x plus g of x times f prime of x. Now we just proved the product rule. Great. That's what we wanted. Great. Yay, I guess fireworks. Yay. Woohoo. Fireworks. We all love fireworks. Woo. I don't know why I like fireworks. It's kind of it's stopping, isn't it? Okay, there. Okay, so one more okay, so like I said at the beginning, what were the other things that I wanted to show you? The few other things. Well, here's one. Why is the derivative of x squared equal to 2x? Now, there's a formal proof of this. There is this proof here. There's this one. And if you want to see this one, if you want to see this proof here, then you can go to my other video about, whoops, sorry about that. You can see my other video about secant lines and derivatives, if you want to. This will show you how to solve for this, right? So but that's not really what we want right now. We want actual proof, like an intuitive proof. Okay, so first thing to notice is that x squared is just the area of a square, right? So we can call this x squared. And remember, the derivative of x is basically just adding a tiny amount to x squared. So let's do that. Let's add a tiny amount to x squared. That's the tiny amount. And let's call that amount dx. Now, notice that this has been composed in 3 pieces, right? These 2 pieces here, and 1 tiny piece. Okay, now remember that dx is a really small number, like, I don't know, 0.0, lots of zeros here, 1. Okay, so basically, we can ignore, well, so we're going to have the area of dx to be these 2 long pieces plus this tiny piece, right? And so notice that this tiny square has a area of dx squared. And remember, dx is supposed to be tiny, right? So actually, we can actually ignore the dx squared because we don't really need it because it's tiny, right? So what we're left with is, let's see, these are both x, right? Actually, we can ignore dx too. So it's just an x length, right? X times dx. Now the dx is tiny, so we can ignore that. So the area, the extra area here is 2x. Now, that's a great representation, if I do say so myself. So I want to do one more thing. Why is the derivative of, well, using the same logic, why is the derivative of x cubed equal to 3x squared? Now, I'm not going to tell you. I want you to put the answer in the comments below. And I actually show you how to prove it in my other video. So I want you to go out and not use this equation and actually come up with an intuitive way like I did with the x squared. Thank you for watching. I hope you liked this video. If you did, please subscribe, like, and share this channel with others. And if you did like it, and if you didn't like it, you can just hit that thumbs down button. Please be honest. Okay, thank you for watching, and see you next time. Oh, and see how to do stuff with Ethan.com. Bye.